question is nonlinear functions. What's our objective, class? Get ready?
Nonlinear functions.
Nonlinear functions. Great curl response, by the way. So we've learned about linear functions. That's just a line, right? Graph of a line. Today we're going to talk about the graphs and tables for a nonlinear one, and they're cool because they're curved. So we're going to talk about parabolas. What are they called? Get ready?
Parabolas.
Parabolas. So if you break it up, it's really like parabola. I remember this because it's the shape of a bowl. It curves down, and it goes up to infinity in both directions, and it's symmetrical right down the middle. You can fold it. But there's also parabolas that go upside down. In high school, you'll learn about sideways ones and hyperbolas and stuff like that. All right. So we're going to focus on cool equations that describe the path of a falling object. In other words, the height of an object from the ground as it's related to time. Okay? So it's nonlinear. They're shaped like a U. If you can think of it's a parabole, like I think of a bowl, that's how I remember it. All right, so look at this object. There's a ball up on the top of a roof. It's 48 feet, and it's dropped. Okay, so it's motionless. There's no speed on it, and it's just let go. And after half a second, it's dropped just a few feet, and then another half second passes by, and it's dropped even farther. Another half a second, and shoo, it's starting to accelerate due to gravity, right? It's speeding up. So by 2 seconds, it's probably going to be down here, right? And it's going to follow that pathway. If it could go through the ground, it would keep on going and follow that nice pathway. So we're going to take a look at a table and graph for that scenario. Luckily, this year, they're going to provide you the equation that describes that falling object. And here's the equation for that particular one. It's y equals negative 16x squared plus 48. The x really is the time. So after half a second, 1 second, 1.5 seconds. The y is really how high above the ground, the height above the ground that the object is. So if we want to find out how high off the ground is the object after a half a second, what we do is we put in the time, half a second. So we're going to put in a 0.5. And row leaders, thank you for getting calculators. We're all going to need this. I'm going to show you how to type this into your calculator. So on your calculator, you're going to type in 0.5. And yeah, thank you. Everyone do this. I'm going to call on students for answers. So 0.5, square it, hit enter. You should get 0.25. Now you're going to type times, and for the negative, there's a negative button at the bottom of your calculator, right by the decimal point button. It's not a subtract button. It's specifically for negative. Okay, it's this guy right here. So you're going to type in negative 16. You'll hit times, and then hit enter, and then add your 48. As soon as you've got to put your hand up. Everyone's typing it in, looking for lots of hands in the air. Jasmine's too angry to type it in right now. Samantha, what'd you get?
24.
Is it 24? Oh, 44. Good, that sounds right. Oh, hey, we forgot to do 0. Let's do 0 real quick. If we put a 0 in here, that whole term goes to 0, right? So we just have plus 48. Let's put a 48 there. Okay, let's do it again. Let's put a 1 in right here. 1 squared times negative 16. Enter. You've got to do that mentally, right? Then add your 48. What do you get? Put your hand up when you got it. Okay, Ethan? 32. Excellent. And then let's do 1.5 right here. Type in 1.5 squared times negative 16. So again, we're using that negative button. Add your 48. What do we get? Sophie? 12. Very good. So then we can take, now the picture above was like a picture of the ball. We're going to do an actual graph. We're only dealing with positive, so I'm only going to work the first quadrant. Let's call this half a second, 1 second, 1.5 seconds, and 2 seconds. This is time in seconds. This one's going to be height off the ground in feet, I'm assuming.
Yeah, it was feet.
It was feet? Okay. Our highest one's 48, so I'm just going to arbitrarily put 40 at the top. I'm going to cut it in half, call that 24. Cut it in half again, cut it in half again, so I know that's 12, 12, 12 more, that's 36. So now I've got my scale set. So at 0 seconds, right when the ball is dropped at the top of the building, we're at 48. At a half a second, we're at 44, which is just a little bit less, maybe about right there. At 1 second, we're at 32. And at 1.5 seconds, we're at 12. So all of a sudden, see how the spacing, it's close, and then the space is farther, and then it's even farther, and you can see it's going to keep dropping. I only recorded half-second increments of time, but couldn't I have done 0.1 seconds, 0.2 seconds, 0.10 seconds? So really, there's data in here, right? I just didn't make my table. So I'm going to connect them, because there is information for time for all of that. But it's curving. So is it going to go like this? No. It's going to keep kind of following that curve. That was really a weird bump right there. It wouldn't bump out like that. Okay, I made it a little bit better. It's going to curve down. So it's got that parabolic shape. Where's the other half of my parabola? I thought parabolas were like a bowl. It's right here. But it's not in our scenario because the ball started at the roof. But how did it get there? So down here would represent the ball before the stopwatch was started. The ball was thrown up. It momentarily came to rest at the top of the roof, and then it came back down. And it's symmetrical. So if it took a little over 1.5 seconds to land in the ground, that means it took a little over 1.5 seconds to get up to the top of the roof. It's kind of cool that way. You can see the graph and you can study where it was accelerating the most. Where did it stop? Where, how high above it when the motion was 0. It's kind of fun. So let's do another one. Did we talk about that it's also called a quadratic function? Remember when we learned like x squared equals 25, and we said that was a quadratic because there's two solutions for x. One is positive and one's negative, right? 5 and negative 5. These functions, when they have a squaring, not only are they parabolic or parabola shaped, they're also quadratic. What are they called? Get ready?
Quadratic.
Quadratic. So anytime you see a power of 2, you know it's quadratic. So we talked about that. So let's do this other quadratic function. And this makes you sound smart when you can say, we graphed quadratic functions. In high school, you'll learn the quadratic formula. It's one of my favorite formulas. All right, so here, let's do a table of values. Now, remember how we said the parabola has a left side and a right side? There's two sides to it. So the only way to get both sides is we have to put some negative values into our table. We're always going to do these values this year. Okay? So negative 2, negative 1, 0, 1, 2. What values do we use? Get ready?
Negative 2, negative 1, 0, 1, 2.
Very good. We're going to input the values for x into x. So we get your calculators ready. We're going to put a negative 2 in for x. I'm going to use another color. Okay, go ahead and calculate that. Put your hand up when you've got it. So negative 2 squared. Oh, does your calculator know if you type it this way, does it think it's this or does it think it's this? Your calculator thinks, if you type it in like this, your calculator thinks it's this. And that would be wrong. Okay? So what we really want, type into your calculator exactly that. So use your parenthesis button and then square. Let me show you which buttons you're going to use. Okay? So here's your parenthesis button right above your 8 and 9. So you're going to go left parenthesis. And then use your negative button next to your period. Negative 2. Then right parenthesis. And then your squared button is right here. Right next to the 7. And then enter, you get 4. We're going to times it by negative 2. We'll times, then hit your negative button, negative 2. Enter, there's our negative 8. So we're going to do that on all of them. We'll whip through these really quick. Okay, who's got negative 1? Colin? Close. Negative 2. Who's got 0? Ethan? 0, right? So we put a 0 right here. We're going to use blue. Okay. What about positive 1? Emma?
Negative 2.
Negative 2. And then what about positive 2? No? Michelle? -8. Now check this out. -8, -2, 0. Is that symmetrical shape we were talking about? Let's graph it and see what we get. So -2, -8, -1, -2, 0, 0, 1, -2, 2, -8. Boom. It's going to come up through this point. It's going to round a little bit. I try not to make it like a V, but it's kind of sometimes hard to get that curve and hits through, and it keeps going. It doesn't like go straight, but it's going to get steeper and steeper, but it's going to keep curving down. Symmetrical about the y-axis, it's pointing down, and that's our parabola. Does it pass the vertical line test? If I draw a vertical line, does it go through one time? Yeah, so it's a function, right? Unless the parabola is going sideways, parabolas are always functions. So let's try this one. I put this on, I added it into the lesson because a lot of students last year, I think it's one of your homework problems coming up, and they struggled on it. So they didn't know how to handle that fraction. So we're going to just practice it real quick. Get your calculators ready. Let's put in -2. We're going to square it. And then how do we do times -1/16? Let's try the -2. That's going to give us 4. Maybe it's easier without a calculator. Emma?
Is it okay if you switch it to a decimal?
You
Or
can still multiply
because
fractions
it's
on a calculator.
What do you get on your decimal?
0.16.
Okay, that would totally work. No, it wouldn't work. It's not quite right. It's close. Liesel?
I got
Negative 0.25. And the fraction version would be -1/4, right? Can you just go, oh, yeah, it is -1/4. Okay, so don't let the negative throw you off.
Yeah, you can multiply fractions on a calculator.
Totally. Do you guys know where the fraction button is? You'll want to know this for your RICE test in 2 weeks. So it's the ABC button right there. That's how you enter a fraction. So you just, if you want to do like 1/16, you do 1 ABC 16. And now it's a fraction. You can hit enter and it'll show you as a fraction. If you want to make it negative, you do -1 ABC 16. Okay. All right, so let's whip the rest of this table out. If we put a -1 in, what do I get? As soon as you know, put your pencil up. So if I put a -1. Who's got it? Weston, you got it typed in yet? Page type in your -1, square it. Okay. Emma?
It's 1/16.
Yeah, it's -1/16 though, right? Be careful, it says negative out in front. Okay, how about 0? But wait, Kaylee? 0. How about 1? Kaylee? Super close. I mean, yes. How about 2? Hannah? This is so weird. So wait, hold on a second. Even though I put positive ones, I still got negative out. I put negative ones and I got negative out. It's because that forced it to be negative. This made it be negative. All right, so let's graph these real quick. I could call it 0.25 or 1/4. It's in the same place. So we've got -2 over, and I'm going to go down a 1/4. Well, a 1/4 is just like a tiny bit, right? Like that's a 1/4, that's a 1/2, that's 3/4. So there's my 4. My 1/16 is even closer to the line. There's the origin. Here's the 1/16, and here's the 1/4. So how do I graph that? Well, I know these are connected, and they're kind of curving, right? So I could assume the curve's going to continue. I don't know exactly where, because I didn't do a bigger table. But I know my parabola is centered about the origin. I know it points down, and I know it's symmetrical. And that's all you need to know for this year of math, right? Not too bad. Okay, last question. You are going to do for your homework, you're going to start at this problem. Let me erase the board so you can see it. And so it's Leslie. She's standing up on the ground. This is her, and her hand is holding a ball right here. She's 5 feet off the ground, and the ball is starting 5 feet off the ground. She tosses it into the air as they start the stopwatch. She goes, boom. All right, and it sends up into the air, and it kind of looks like this is the ball. It's not really the ball, but she sends it up. After 1 second, it reaches its max height. It comes to a very, very instantaneous stop as it changes direction and comes back down. And then at 2 seconds, she's standing there and she catches it. She's still 5 feet off the ground. if she were to move her hand and let the ball continue going, the ball would go, when did the ball hit the ground? It couldn't go like this, right? It almost looks like it could. Because at 2 seconds is when she caught it, so if she moved her hand, it would have to take another split second to keep traveling, and then it hit the ground. Okay, so if the question said when does it hit the ground, it's just a little bit after 2 seconds. All right. What you're going to do is you're going to figure out, let me shrink it down a little bit. You're going to figure out what these values are in this function, and the reason why some of the students have struggled is because there's 2 t's. So here's how you do it. If we want to find out when t is 0, you're going to put a 0 in everywhere you see t. I know that's super tiny. I can make that a little bit bigger for you. Okay. Right there. So everywhere you see a t, you put a 0, and now you type that in, add it all together, and that's where you put your table. So if t is 1, you put a 1 right there. 1 and 1. And type it all in your calculator and just get an answer, fill out your table. You're going to do some graphs, and you're going to answer some questions. So here's your assignment. On page 727, you'll do questions 3, 4.